Slack refers to the difference of earliest start and latest finish time. Activities that have slack time can be delayed without causing a delay in the entire project. These activities are not on the critical path. The determination of slack and critical path depends on the calculation of earliest start in the forward pass and latest finish time in the backward pass. We now show you how the forward and backward passes work. For the forward pass, we start at the first node and calculate the earliest start time. The earliest start time is usually the maximum of the earliest finish time of the previous activities. The earliest start time for activity A, selection of satisfaction surveys, is at week 0. Earliest finish for activity A is the earliest start time plus the duration, in this case 2 weeks. So the earliest finish time for activity A is on week 2. Let's now look at the earliest start and finish times for node B, printing of survey tool. As before, the earliest start time of an activity in the maximum is the maximum of the earliest finish time of all of its immediate preceding activities. Activity B has only one precedent and it finishes on week 2. Therefore, the earliest start of activity B is on week 2. The earliest finish time is calculated as the earliest start time plus the duration. The earliest finish time for activity B is 5 weeks. The earliest start and earliest finish for activity C is calculated to be on weeks 0 and 1. The earliest start and earliest finish for activity D is calculated to be on weeks 1 and 2. The calculation of early start and early finish for activity E, mailing of the surveys to the patients, is more complicated as there are 2 precedents for this activity. The earliest finish for activity B is on week 5 and for activity D is on week 2. We select the maximum, which is 5, for the earliest start date of activity E. The earliest finish date is then calculated as 5 plus the duration of the activity. The earliest finish date for activity E is week 7. Here we show the earliest start and earliest finish dates for activities F and G. Since G is the last activity, it follows that the earliest time this project can finish is in 14 weeks. In the backward pass, we calculate the latest finish and start time. The latest finish is calculated from the minimum of the latest start of the succeeding task. Since there is no task succeeding task G, we start with the earliest finish time of this task. In task G, the latest finish is week 14. The latest start is the latest finish minus the duration. In task G, the duration is 3 weeks, and therefore the latest start is week 11. For task F, the task of collecting responses, there is one succeeding task. The latest start of task G is week 11. Therefore, the latest finish of task F has to be week 11. Given that the latest finish is week 14, then the latest start has to be week 7. The same calculations can be done for the remaining tasks. Having calculated the start and finish time for each activity, we are now ready to calculate the slack time associated with each activity. Slack is the difference of the earliest and the latest start times. In most of the activities in this example, the earliest and the latest start time are equal, and therefore the slack is 0. In activities C and D, the slack is not 0. These activities each have a 3-week slack. Therefore, these activities are not on the critical path. Delays in these two activities of up to 3 weeks will not delay the entire project, but the activities in green have no slack time. These activities on the critical path and delays in these activities will delay the entire project. It is important that project team members understand the impact of their activities on the entire project. For this reason, it is necessary to communicate to the project team the network of activities and the critical path through them. This can be done effectively through a time-scale network of activities on the node. In addition, it helps if the team members can see a Gantt chart of the activities. Communication can be further facilitated if the activity completion and time in an activity are marked on the charts by changing the color proportionally to the extent of the activity completion. Activity splitting can shorten project completion if it allows earlier start of subsequent activities. Recall from our previous example that it would take us 14 weeks to start a survey of patient satisfaction to completion of analysis of the data received from the patients. This time can be shortened by splitting some of the activities. Collecting patient responses is projected to take 4 weeks. We are planning as if we have to wait the entire time for all the responses to arrive, but it's possible to start some analysis beforehand. In particular, we can analyze early responses to predict the complete response of the patients. If we break collecting data into 2 activities, one activity named as collecting early responses and the other named as collecting late responses, then we can start the analysis sooner. As late responses arrive, they're added to the analysis, but the core analysis starts after the early data are available. This way, the project can finish several weeks earlier. Before, analysis would only start after the collection of late responses, but now, analysis and collection of late responses should finish together, thus reducing significant waiting time. The discovery of critical path has been significantly simplified in modern project management software. There is no longer any need for calculation of early and late start times. These values are calculated by the software themselves. It's possible to speed up schedules by making more resources available. Most activities can be done faster if more people are hired to do it. When activities are speeded up by spending more money, it's called crashing the schedule. The critical path method allows us to detect how much time is saved by crashing a schedule. Then, managers can decide if it's worthwhile to spend the initial money to speed up a task to save a certain number of days in terms of project completion date. Since different activities lead to different time savings, activities are crashed in the order of time they shave off the project's end. The take-home lesson for this lecture is how to calculate the critical path for a project through a calculation of slack time for activity, which is the difference of the earliest and latest start time of the activity.